Okay, so let's get a little deeper about our graphs. At this point where we know a graph to be, it's essentially a visualization of data. And how we collect that data depends on a lot of different items. But in mathematics, the way we create this data that I'm going to visualize in a graph is by looking at an equation. So everything is related to an equation. Now recall back in chapter 2, we defined a solution to an equation to satisfy three things. The first thing we had to do is find a value or values for the variable. We substituted those values into the equation, and then we saw if we got a true statement or not. If we were able to get a true statement, it was a solution. If we weren't able to get a true statement, it wasn't a solution. And so by looking at these values, we create data points that we can eventually visualize in a graph. So check out, this is going to happen. So let's just consider the equation x minus y is equal to 3. All right, so to solve this equation, I need to find values for x and y that when I substitute them in, make them true. And I chose kind of an easy equation because I think we can just think, what two numbers have a difference that's equals to 3. And so thinking in terms of ordered pairs, right, 7 and 4 come into mind. X is 7, y is 4, and so when I substitute those two values in, I get a true statement. So there is a solution point to that equation. It satisfies, I found some values, I plugged them in, got a true statement. And we can do this for quite a bit of them, right? So, how about 5, comma 2? So if I substitute those into the equation, 5 minus 2, well, that gives us 3 equals 3. So again, we found another solution. So we have two solutions so far. And again, if we just thought about it, we can probably find more, right? So let's try something like 1 and negative 2. Throw some negatives in there. So if I put this into the equation, I get 1 take away negative 2. If we subtract a negative, that's the same thing as adding an opposite. And we get 3 equals 3. So I have another solution right there. And as you can kind of get a feel, we can probably do this all day long. So when I'm being asked to find the solutions to x minus y equals 3, there's actually an infinite number of them. We just found 3, and I'm pretty sure sitting there at home, and if I was to do this again, we'd be able to find even more. So how do I find all the solutions to the equation when there's an infinite number of them? Well, what we do is we turn to a graph. Right? Because now what I have, since I have some ordered pairs, I can come over to a grid, right? So let me draw a nice little grid here. So there's our x-axis, and here's our y-axis, and I can start plotting these points. So let me start with this point here. So 1, negative 2, well, when x is 1, y is negative 2, puts us right at that location there. So that's an ordered pair. That's a data point, right, that satisfies that equation. So we're starting to visualize the data. 5, comma 2. So x is 5 and y is 2. So there's another piece of data. And I'm going to probably have to extend my graph out a little bit more. Right? So when x is 7, right, y is 4. And you start to see that the three data points that I have, they all line up really nicely. So that means any other ordered pair you can think of is going to fall along that line. So we basically connect the dots, throw some arrows on that. Those arrows are very important because that's indicating that this goes on forever. So every single ordered pair along this graph satisfies that equation. For example, you can kind of get a feel, all right, that this point right here, which is the point 2, negative 1, right, satisfies the equation. 2 take away negative 1 equals 3. 2 plus 1 equals 3, 3 equals 3. So that's a point that we didn't consider, but after graphing it, we can see that it actually is on the line. Same thing with that one right there, right? That's the point 3, 0. And clearly that satisfies 3 minus 0 equals 3. So that also satisfies. So the idea then, a graph, right, not only is it a visualization of data, but in mathematics, it's basically a visualization of the solution points to an equation. And this is where the math actually becomes very alive, if you will, because we can start visualizing it. So every time you see a graph, let me just kind of create a graph. Maybe we had a graph that was looking this crazy, right? When you guys move into Math 150 one day, you'll take a look at graphs look like that. That picture, that graph, is a visualization of some equation. All the points along that curve satisfy some equation. All right, and so again, I know you guys don't know that equation. We're not in Math 150, but this is where this is heading, just to kind of give you guys a glimpse into the future. So again, a graph is basically a visualization of the solution points to an equation. Our only job is to figure out, right, what ordered pairs make it true. We plot them and we start seeing a pattern. In this case, we got a nice linear pattern, and we basically get a graph. And so that's all a graph is. So really, when I ask you to graph an equation, I'm asking you to actually solve an equation. And so now the challenge is, right, how do we find solutions, right? How do we get our solution points is now the question. And that's actually in the next video. So there's your introduction to what a graph is in mathematics. Again, it's a visualization of solution points to some equation that's given. And we'll talk about how to find those solution points in a more complicated situation in the next video. All right. Again, text me or email me with any questions. Jump on Canvas and ask them. All right, and we'll take care of business. See you guys in the next video.